So, yeah, in general, different voice leadings correspond to different paths between the same points.
All right. Due to the constraint of time, I think that we should maybe have one or two questions. Anybody would like to ask a question? Yeah.
I'm Luis Chen from here, from NUS. Now, in computational biology, there is a sequence comparison to detect similarities between DNA sequences. There is also this phylogenetic trees to search for common ancestors. So it seems that if you have a geometric representation of music, one can do similar things. But of course, is there a need to do this on music? If so, has this been done? Or how much has been done? I'm really interested to know.
The question are phylogenetic trees used to explore musical phenomena? Is that the question? No. Maybe you should ask the question again.
Well,
Did I understand the question?
in the first paper I published in Science called The Geometry of Musical Chords, I do, in supplementary materials, I do actually use a kind of dynamic programming that's used in DNA sequence matching to find the optimal voice leading between chords in the case where you can double notes arbitrarily. So that's actually a complicated problem. And so there are cases where some of these standard computational tools that you find in the biological world or just in applied mathematics more generally also appear in music. I imagine that things like Chris Raphael was doing, where you're trying to match, you're listening to a performance and matching that against what you know should happen in the performance. That can also, that's a case where you might find these same techniques appearing. So there are these kinds of things. You find applications for computer tools.
A lot of work been done in this.
What?
A lot of work been done in this kind of
Not
comparison.
a lot of work, no, some work.
Go ahead.
Yes, I can add something because I have worked with the Genomic French Center in another life. There have been attempts to musify, to give a sonification of the DNA with the hope to locate genes, because the gene localization is a difficult problem. And the idea is that there is a bias in the codon, and then if we associate some notes with each codon, perhaps we can listen where the genome is more organized. It's a failure. It does not work. The bias, the statistical bias is too lower. But at a higher level, for example, now if you are looking at phylogenetic tree, people are using algorithms to make clustering or classification, especially in cladistic, and the kind of formal concept analysis I show you have been used also for doing that.
The one piece of work that I would refer you to that I'm aware of is a book by Gottfried Toussaint, who's a Canadian, actually Belgian-Canadian computer scientist who has become a music theorist in his retirement. So you may want to have a look at his book, A Geometry of Rhythm.
Yeah, and he does use phylogenetic trees to try to trace the development of certain rhythmic languages.
Thank you.
All right, just maybe one more question. This gentleman up here. Oh. I think between the two of you, maybe one.
Thank you for the presentations. If I understand well, you make graphic presentations of pitch, times, and relation to it. Maybe as how do you can add specializations of sounds to this kind of representations?
By sounds, you mean timbre?
Like seems like it's a monochrome channels. Each note it's a path or just one note. But if we have like many speakers, for examples, how can we like after link these kind of representations to? Is it a possibility to?
Sure. Well, you know, it's sort of the sky's the limit in terms of what your imagination, you know, whatever you can imagine. The geometry stuff that I have been working on gives you a principled means of translating between musical and spatial information. There is some really interesting work being done at Princeton with very precise spatialization. So just two speakers, but there's a guy in the engineering department who can make a fly sound like it's buzzing around your head only with two speakers. So you could actually imagine a kind of music where, if you could spatialize very precisely, where chords appeared to emanate from the location in physical space corresponding to the voice-leading relations among those chords. I think right now that's just a little bit beyond the realm of possibility, but it's probably not too far beyond it. So really there's a whole world of these kinds of analogies, and doing things with spatialization is certainly on the horizon, I would say.
If you have 6 speakers in the round, like Boulez was doing in the, I think, 1980s, Dialogue de l'ombre double, for example, you can do a modulo 6 space, and 2 speakers that are next to each other are one pairing, and 2 that are next adjacent are another pairing. You can treat it like a whole tone scale. That's not geometric, but it's a mathematical or group theoretic approach.
Good. I think on that note, we should end this session. I think that is quite a good quote there, that sky is the limit, and we look forward to the panel discussion where we talk about musical futures. Thank you very much. Thank you very much for the speakers.